12 people hit forgot password at the same second. The page dies. Those people were not attackers. They were the retry button. A password reset is a slow write, and a slow write has a finite number of workers. The write is a hash of a secret and a row stored in the database. That work holds a worker for about 400 milliseconds. While that worker is held, it cannot take another request. The write is slow on purpose, because a hash plus a row is not a cheap read. A process has a fixed number of workers. On this box, that number is 4. A worker is one request being handled. 4 workers means 4 password resets can sit in the write at once. A 5th request has no 5th worker because the pool does not grow when the queue grows. Adding servers later does not help the second that is already on fire because a new process is not instant. Semaphore 4 is a counter of free slots. Acquire drops it by 1. Release puts that one back. When the counter is 0, acquire waits. We wait 200 milliseconds so the caller is not held forever. Then we stop waiting. The slot list is shared. A lock exists so 2 threads cannot take the same slot. Without the lock, 2 requests can both read a free slot and both write busy, and then 1 worker is claimed twice. When all 4 are held, acquire returns nothing. We answer 503. The reason is workers busy. 503 means the server cannot take the work right now. It does not mean the client was wrong. The client sent a valid reset, and the pool was full. A client that waits too long times out and retries. 12 clients do the same. The retries are not a second wave. They land on top of the work that is still running. That is the stampede. The first write is still the hash and the row, and the retry does not know that. Without a limiter, every retry is new load. The 4 workers stay busy. The next request waits a short time for a free worker, then we answer 503. Those 503s are the pool, not a wrong password. The password reset falls over under load it created. A limiter is a gate that decides how many may enter. It sits in front of this pool. It cannot invent a 5th worker. We need a gate that lets a short burst through, then holds the rest to a ceiling the write can actually finish. The limiter we build is a token bucket. A token bucket is a counter of tokens. Each request spends 1 token to enter. Time adds tokens back at a fixed rate. If the counter is at 0, the request waits, or we refuse it. Capacity is the burst. 5 tokens means 5 requests can enter at once, even if nothing has been added yet. After that, the bucket is empty. Set capacity to what the downstream can absorb. Too small, and we clip honest traffic. Too large, and the stampede still wins. Rate is the refill. 2 tokens a second is the sustained ceiling. After the burst, a new request can enter every half second. We measure elapsed time, add rate times elapsed, and clamp to capacity so unused tokens do not grow forever. That clamp is what stops a quiet hour from becoming an unbounded burst later. 5 tokens is 1 more than 4 workers, and that extra token is the seam. A small burst is fine. Then 2 a second matches a write the pool can finish. The bucket keeps 5 pieces of state. Capacity is the most tokens it can hold. Rate is how many we add each second. Tokens is how many are in the bucket right now. Last refill is when we last added. A lock makes sure 2 threads cannot spend the same token. We read time, monotonic, not the wall clock, because a clock step must not invent tokens. Wall clocks jump when NTP steps or a time zone changes. A monotonic clock only moves forward. Elapsed time is a duration, not a time of day. The bucket sits in front of /reset. A request spends 1 token to enter. If the counter is at 0, the request waits. After about 2 seconds with no token, we refuse it with 429, and we never take a worker. The wait cap is 2 seconds, so we do not hold the caller forever. 429 means too many requests, and the limiter refused this one before the hash starts. The class stores rate, capacity, tokens, last, and a lock. Wait sleeps outside the lock until a token lands, then spends it and returns the milliseconds we waited. The semaphore is the 4 workers. If wait exceeds 2 seconds, we return 429 and the write never starts. A retry without a budget is how a 503 becomes 12 503s. Each timeout looks like a new client. The box cannot tell a first try from a third try unless the client carries a budget. 3 attempts is the budget on this stampede. After that, the client stops. Without that stop, the table never ends. Allow is the path that never blocks. It refills, then spends or refuses. Wait is for the caller that can block. If the bucket is empty, we compute how long until the next token lands. Sleep that long, then refill and spend. The sleep sits outside the lock, so other threads are not stuck. 12 clients hit/reset together. Each attempt retries on a timeout, or a 503 up to 3 times. The table fills with 503s. Workers stay at 4. Retries keep arriving. Attempt 2 and attempt 3 are the same 4 workers still held by the first wave. The same 12 clients go through the bucket. The first 4 land on a worker. The 5th spends a token and still hits a busy worker, then waits for the refill. That 5th token into 4 workers is the seam. Later requests wait about 500 milliseconds. 4 late requests hit the 2-second ceiling and we return 429. Workers drop. The downstream stays up. A 429 never starts the write, so the hash and the row stay off that request. The pool answers 503. The limiter answers 429. The client should not retry a 429 as fast as a 503. A 503 can clear when a worker releases. A 429 clears when the refill adds a token. Retrying a 429 immediately is the same no. A 503 may spend the retry budget. A 429 must not spend the retry budget. Mixing those two reactions is how 12 clients turn a refusal into a stampede. Shedding load means we refuse now and we free the caller. Queuing means we hold the request for a bounded wait until a token appears. The password reset box queues on the bucket for up to 2 seconds, then sheds with 429. It sheds with 503 when the pool is full and the short acquire expires. An unbounded queue is not kindness, because memory grows while the fire stays hidden. A box that stays up still has to show us whether the contract is holding. Workers in use, tokens left, and the 429 count are the 3 gauges. Workers at 4 means the pool is full. Tokens at 0 means the ceiling is in force. 429s climbing with workers below 4 means the limiter is doing the shedding. A 200 with about 500 milliseconds of wait is the rate working. The request spent a token that had to refill. The write then held a worker for about 400 milliseconds. That row is success under the ceiling, not a stall. Capacity is the burst. Rate is the ceiling. The lock is the critical section. The workers stay up because the bucket, not the semaphore, absorbs the stampede. The 5th token into 4 workers is the seam we still read in the with table. 503 is the pool, 429 is the contract. The client should not treat those 2 no's as the same no. Thank you.